All right, let's get right into it. Today, we're going to pull back the curtain on something pretty cool: how massive, enterprise-scale Cisco wireless networks actually work. It's time to crack the code on centralized Wi-Fi.
Have you ever stopped to think about it? You walk into a huge office or a university campus and there are hundreds, maybe even thousands of Wi-Fi access points. How on earth do they all work together without it just being, well, a complete and total mess?
Because let's be real, if you had to log into every single one of those APs one by one just to do a simple firmware update or change a Wi-Fi password, oh man, that would be a network admin's worst nightmare. And that is the exact problem a centralized setup is built to solve.
So, what's the secret sauce here? How do they pull this off? Well, the magic behind this whole thing is a special protocol. It creates this kind of tunnel between all the access points and one central brain. And that protocol is called CAPWAP.
Now, CAPWAP, that stands for Control and Provisioning of Wireless Access Points. It's the official industry-standard protocol that lets a central box, called a Wireless LAN Controller, or WLC, manage all of what we call lightweight access points. Think of it as the universal language they all speak to each other securely and efficiently.
Okay, so the best way to think about this CAPWAP tunnel is like a secure two-lane highway. In one lane, you've got the control tunnel. This is like the management lane for official vehicles only. It carries all the instructions from the WLC, things like new configurations, firmware updates, you name it. Then, in the other lane, you have the data tunnel. That's the express lane, the high-speed lane carrying all of our actual traffic. You know, your web browsing, your streaming, all that good stuff.
All right, for all you tech spec lovers out there, here's the quick rundown. CAPWAP is a UDP-based protocol which helps keep things fast. It's all officially laid out in RFC 5415. And super importantly, it supports DTLS encryption. Why does that matter? Well, it means all that critical management traffic is locked down and secure.
Okay, so we've got our CAPWAP tunnel, our highway. But now comes the big question. It's a huge architectural decision that every network engineer has to make. How exactly are we going to use that highway? This brings us to a fork in the road, and the two main options: local mode versus Flex Connect.
And really, the choice between them boils down to this simple question. It's one thing if all your access points are sitting right here in the main headquarters building, all connected by a super fast local network. But what about that small branch office you have across the country? The one that's connected by a much slower and probably way more expensive WAN link.
So here's the fundamental difference, the real key takeaway. In local mode, all of your traffic, every single packet, gets stuffed into that CAPWAP data tunnel and hauled all the way back to the central WLC at headquarters. This is great for a single campus, but with Flex Connect, the traffic from that remote office can be switched locally. That means it breaks out right there at the branch and goes straight to the internet, without ever needing to cross that slow WAN link back to HQ.
And this, right here, is the crucial trade-off. Local mode is beautiful in its simplicity. Everything, your configuration, your troubleshooting, it's all in one central place. The big downside? All that traffic eats up your precious WAN bandwidth. Then you have Flex Connect. It's super efficient. It avoids that ugly traffic tromboning back and forth, and it can even keep working if the WAN link goes down for a bit. The catch? Well, now things get more complex. You have to manage network settings like VLANs at every single remote site.
All right, let's make this practical. We've got the theory down. So how in the world do you actually choose which mode is right for your network?
You know, I saw this quote from a network pro on Reddit, and it just hits the nail on the head. They said, Flex Connect is great for some use cases, but in general, I would stick to local mode as much as possible. And that's really the golden rule here. The simplicity of local mode is it's so valuable. You only want to introduce the complexity of Flex Connect when you absolutely have to, like for those remote sites over a WAN.
So let's break it down into a simple cheat sheet. You should probably use local mode if all your APs are in one place on one fast campus network, or if you want the absolute simplest way to manage and troubleshoot things, and maybe if you have security policies that require all traffic to pass through a central point. On the other hand, you definitely want to look at Flex Connect if you've got those remote branch offices, if you're trying to save that WAN bandwidth, and especially if you need the Wi-Fi to stay up, even if the connection back to headquarters temporarily dies. All right, but let's be honest. In the real world, even the most perfect designs run into problems. So let's talk about one of the most common and most frustrating issues you're likely to face.
Oh, it's a classic, all right. You get a call, someone's phone or laptop says it's connected to the Wi-Fi. It's got full bars, they put in the right password,
but nothing loads. They can't get to the internet. And when you look, you see they never got an IP address. So, what's going on?
And if you look at a troubleshooting screen like this one, you can see exactly where the process breaks down. See? The client associates, that's good. It authenticates, also good. Everything is going great, and then, bam, it just gets stuck right here at the IP address assignment step. When you see this, 9 times out of 10, you're looking at a DHCP problem.
So, where do you even start to fix this? Here's your quick checklist. First, can the WLC even reach the DHCP server? Just a simple ping can tell you that. Second, check your DHCP scope. Is it possible you've just run out of IP addresses for that network? And here's the big one, especially for FlexConnect. Did you remember to correctly configure the switch port the AP is plugged into? It needs to be a trunk port that allows the client's VLAN. A simple mismatch right there is, it's a super common culprit.
You know, when you step back, this all comes back to something bigger. It's not just a technical choice, it's a strategic one. There's no single best answer here. You have to decide what matters most to you. So the real question you have to ask yourself is this. For your network, are you centralizing for simplicity and control, or are you distributing for performance and resilience? Because the answer to that question, well, that's what's going to guide your entire design philosophy from the ground up.